Hi, everyone. I feel like I haven't seen y'all in quite a while. Well, for this video, I'm going to go over one of the toughest parts of the first lab assignment to grade. It's hard to grade because it's kind of subjective and everyone's answer is going to be slightly different. And I think from here on out, I'm just going to make this specific video available to all students moving forward in this class so that they have just a better idea of how to go about tackling this specific problem. I'm going to make a separate video where I go over the answers to the first lab assignment, assuming I don't change the questions. And that one, of course, will be hidden until the first lab is done. But for this one, I asked you to make a histogram of the tomato meter scores for your director. It can be your favorite director. It can be a director you hate. But it had to be a director that had a pretty decent amount of movies already made, or else this assignment wouldn't really work. And I asked you to describe the distribution of the tomato meter scores using some of the terminology that we learned in the class. So starting off right here, we've got Tim Burton. I like Tim Burton, especially before he started making terrible movies. He used to make good movies. I don't know why he decided to start making terrible movies. Let's see. I'm going to describe them first, and then I'm going to look at the anonymous student description and comment on that. So my first impression is that it has a very high peak, like 82 and above. That bin in the data is the highest one. It's got 8 movies in there. And it almost, you're tempted to say it's like this great, like high peaked at the max and just has a nice negatively skewed tail going down to the bottom of the range. So it almost looks like it's negatively skewed with a very high peak. The only thing that really messes with that is this little lump of data. These 4 movies right here kind of messes with that trend. If you change the bins up a little bit, you might not see this exact pattern. Google Sheets is the most user-friendly way I've found so far to make quick and easy histograms. But my one gripe is that it defaults to like bin values that, will change what the distribution looks like. I'd prefer it to start at 0 and end at like 90 plus and go in 10 tomato meter score increments, but maybe in the future. So that's my assessment. Let's see what the student said. His tomato meter data is not flat. That's true. If it were flat, then like everything would be more or less at 2 or everything would be more or less at a 4. It's not flat. It definitely has a pronounced peak. There is more data in the high average rating. I guess they mean most of the data is high. I agree with that. But there's no averages. I mean, these are just frequencies. How often do movies from this value to this value appear? So this is like the data itself without any averages. But I think what they meant was most of the movies are in this top bin right here. However, there is also much data in the median rating. I think what they mean is medium, like in the middle of the range. If they mean like if this is like the medium, like there's low, there's high, and then there's in the middle, there are a lot in this middle part here. You want to be careful though, because mean and average, that's a name for a summary of this data. A median is also a summary of this data, but this is the data itself. But I take them to mean that there's a lot of movies in the medium part of the range. The data appears to be bimodal. I agree with that. There's definitely one mode, like the main mode up here. And like I said in the beginning, the data seems to kind of skew left or skew in the negative direction, except there's this one lump or extra mode over here. So I can definitely see the argument for calling that one bimodal. I wonder if these are all these, Tim Burton's been making all these remakes I wonder if that's where all that's going, because I'm not a big fan of all these remakes he's been doing. His original stuff early on, I think, were a lot better. Next, we have Clint Eastwood. Very interesting choice. So my reaction is he's done a lot of movies. Are these movies he's directed? I know he acted in a lot of movies. I didn't know he directed this many. Yeah, from about the 50-ish to the 100 range, you've got a pretty flat, like there's no real pronounced peak. It's just kind of a plateau of like 50 and above is a plateau. And then there's a drop, and there's like 2 movies that are in the 30 to 40 range, and there's 2 movies in the 20 to 30 range. So our typical terminology that we went over for this class is not going to do you any favors. It's pretty much flat. It's flat between one range and it's flat between another range, but at different levels. So this student probably would have struggled to describe this with the terminology we went over in the chapter. And I guess partly that's on me because I didn't anticipate. There isn't really standardized language for describing this kind of distribution. So let's see. They say no, it's not flat, and that's true. Overall, it is not flat. There's definitely a drop off. So that is true. According to the histogram chart, I believe it reflects a good amount of success throughout his career as a director. I'd agree with that. There were 4 films that didn't score well at all, below 50. Very true. So this student's making true observations about the data in place of, the terminology of bimodality, skew, peak, and all that wouldn't have helped much. I respect that. The histogram shows that it starts to peak after the first 4 films. So I guess they mean that you could consider these 4 bins over here to be the peak, collective peak. It's not usually what people mean by peak, but that's fine. He had a total of 15 films that scored between 50 and 73. Yeah, I guess. Clint had a total of 20 films that did very well, scoring between his data according to the Smiths, or peaked pretty high, I would say. Peak even higher. Yeah, they basically go on in so many ways to state a bunch of facts about these top 4 bins up here have the most movies in them. And in a way, you could think of these collectively as one big flat peak. You could say 73.33 to 86.67 is the peak, but that would be kind of, I don't know, that wouldn't feel quite right. So this was a tough one. And I don't think this student lost any points. I actually didn't grade, my academic assistant graded these. But if I was grading this, I would have said, good job, you plotted the data correctly as intended, and you used some terminology, but also that terminology wouldn't have been very helpful, so you kind of got around that. So good job on Clint Eastwood. Who's Baz Luhrmann? Let me look that up. Baz Luhrmann. Elvis. That is one of the. Who's Baz Luhrmann? Australian film director. His writers, some particular example. Auteur for his style. What has he directed? Films. Interesting. I haven't seen any. I saw Moulin Rouge a long time ago and Romeo and Juliet a long time ago. I guess I can definitely see a trend. Those are similar-ish kind of movies, but I haven't seen any of these other ones. Very interesting. But let's look at his distribution of scores. Now, just from the Wikipedia, it didn't look like he directed that many movies, but here we've got 1, 3, 7, 9 movies. I guess sometimes they don't list everything, but yeah, this is a tough one to describe because it's like you got this one clump of scores down here and this other clump of scores up here, and neither of them really have much of a distribution to them. That's why it's good to pick directors with lots of movies because an actual distribution takes shape. This is kind of a disconnected, disjointed kind of data distribution. But let's see what the student said. Yeah, how would I describe this? I don't know. The typical terminology would not do too well here. The distribution is not evenly distributed or flat. That is true. Good job. And peaks between 73 to 89. That's true. This is, I mean, this is the mode right here. It feels weird calling this the mode because there's not really a sloping tail going down in this direction because there's nothing in this bin right here. But that is accurate to say that's the peak. This shows a relatively competent director. Yeah, I'd say so. The peak is relatively high, and it appears that Lerman didn't have any average films, as there is a gap in the plot between this and this. Yeah, he is kind of all or nothing. It was either highly regarded or low regarded. Yeah, I'd agree with that. The films are either clustered, oh, I like that, clustered in the bottom such and such or the top such and such. It's hard to see with the range, not on a scale of 0 to 100%. I completely agree. But if it were, we may find that the 14, 15, whatever film is an outlier. Well, I don't see a 15 to 41 unless you meant 25 to 41. Maybe it'd be an outlier. I don't know. With this little data, it'd be hard to say something's really an outlier. I don't say this in the class, but one of the definitions for an outlier is if the observation is more than 4 or 3.5 or 3, I forget, it's arbitrary anyway. If you're like so many standard deviations away from the rest of the data, you can use that as a cutoff for outliers. Outliers actually it can be a pretty slippery concept. I don't know if I agree that if they're referring to this film right here, I don't know if I'd agree that that's an outlier, but you know, I wouldn't have taken points off for that. It looks almost bimodal, but there isn't enough data to be sure. Yes, it does look bimodal. And the exact thing I would have said, but there's really not enough data, is exactly true. So overall, well done. This is why I would caution students to use directors with more films because you run into this problem, but they handled the problem pretty well where the terminology kind of breaks down because there's not really a continuous looking distribution. It's kind of these two clumps. All right, who we have next? I think I just basically took the first 5 students that replied to my email asking if I could use their work. And I appreciate all the students who replied saying I can use it. It's nothing personal if I didn't use yours. I just went with the first like 5 people who responded. So here's Steven Spielberg. Everyone loves Steven Spielberg. Jurassic Park, Catch Me If You Can. So many greats. And I haven't even seen some of his like highly regarded stuff. Like I don't think I've even seen Jaws. I'm such a plebe. Yeah, so how would I describe this? He's got this great big peak up at the top of the scale, and it kind of slopes down into a negative skew. If you change the bins to make them more fine-grained, you'd probably see more of a smooth tail going downward. That's the problem that keeps coming up with Google Sheets is the binning is not easy to change. And I don't want to jump ahead of what the student said. So let me go to what the student said. It's not flat or evenly distributed. Yes, very true. It's not flat. There's definitely a peak. Most of Spielberg's tomato scores are clustered. I like the use of clustered between 2 peaks. I don't know if I'd call these 2 peaks. I'd say this bin is the peak. Usually you only have 1 peak unless it's bimodal. Then you have like the main peak and a side peak. That's an interesting phrase, side peak. Yeah, making it bimodal with a negative skew due to the outlier at 31. Yeah, you could probably actually call that an outlier. I'm more comfortable calling this an outlier compared to this, for sure. The one specific movie is on its own, and due to the limited amount of data, it is not necessarily a separate mode. I completely agree. That's a great observation. What's the difference between a second mode and a mere outlier? An outlier is just like one, maybe two observations that are just off on their own part of the scale. So this one movie would be a pretty good example of an outlier. And I'm curious to know what movie that is. I mean, I know Spielberg's probably made some stinkers. He just made so many movies, but I'm curious which one stunk this much. But yeah, a mode, that's tough. If there's enough data and this, like, if this was a clump of like 12 films and like you had hundreds over here in the main distribution and you had this like kind of second little clump by itself and it's really like a substantial amount, that'd seem more like a mode. So you're seeing from this exercise that some of this terminology can be used somewhat loosely. There are more formal, more stringent definitions you could use, but I like to respect kind of the more natural, more informal way that people talk about data at times. I don't like to pretend that uh, statisticians and researchers always stick strictly to the formal meanings. So I'm glad we got to talk a little bit about what's the difference between this outlier is not a second mode. I'm glad we touched on that. And this is the last one. Spike Lee. I did not know Spike Lee has directed so many movies. I guess he has been around for a long time. And I love that these bins are very fine grained, so you can see the distribution a lot better. I didn't look too deep into like how to change the bins, but this looks like it's either been altered by the student somehow, or maybe because the scores are spread out so much, it defaulted to just more bins overall. I don't know. It looks like it's going by fives, so I think the student may have messed with it, which is good. So how would I describe this? Definitely a peak right here around the 85, 90 area and a nice negative skew. And you can see since the bins are more fine grained, you can see that the skew is more pronounced and more smooth. So this is a high peaked, negatively skewed or left skewed distribution. The chart is not flat because the data is not evenly distributed throughout the chart. Very true, good job. It also seems to be skewed to the left since most scores are clustered at 80% or above. That is, yeah, most of it's clustered at 80% or above. The reason it looks skewed is because you got this downward sloping tail kind of trailing away from the peak. I'm sure that's what they meant, but make sure to say what you mean, not just what, you type something that might not necessarily literally be what you meant to say. There doesn't seem to be any outliers on the chart. Very true, I agree. And since the chart has two peaks, it's bimodal. I don't agree that it's bimodal. If you took out this movie, these three, and these three, then you could call this one over here an outlier since it's by itself. But because all these movies are right here, this is not really an outlier. And I guess maybe what they were thinking is maybe this is a mode, a second mode right here, maybe. But kind of like with the previous one, a mode, calling something a mode kind of suggests that there's a substantial amount of data. And these are just four movies right here that are part of the overall trend going downward. So I wouldn't really call that a mode. Yeah, so thank you everyone who agreed to share these, and I hope this helps current and future students. And I'll see y'all next time.